All right, we're back. This is going to be page 88 of math analysis. We're still in notes 8. We're solving trig equations. We basically know everything at this point, so I think it's pretty much just practice from here on out. But let's see what we can do. So I don't know. Solve each equation. All right. So what quadrant? Sign it's positive. So that's whoa. What is that? 1 and 2. Reference angle is the sine inverse 0.6542. Which I'm going to do a copy and paste here to save me some time. Save all this some time. All right, so then the angles are, what are we solving for, x? Nope, theta. Theta, right in with the lasso tool. Theta is going to be equal to, in quadrant 1, you know, it didn't save any time. Quadrant 1, oh, maybe I may have just learned something. I think you can't paste when you have the like marker. You have to paste when you have a lasso tool. And then in quadrant 2, it's going to be pi minus the reference angle. And you can see there's no way I'm going to get all these inside the box. I'll get them in the row, but not in the box. Cosine and its negative is 2 and 3. Our reference angle is the cosine inverse of the absolute value, so 0.8542. And then here we go. I'm gonna try to save us some time. So I'm copying. All right, so in quadrant 2, we're gonna do theta equals pi minus the reference angle. Oh, that's definitely it. I just unlocked the mystery of the pasting. And then in quadrant 3, it's gonna be pi plus the reference angle. And there we go. All right. Tangent and it's positive, so that could be 1 or 3. But we want to do, we're going to do just one thing, right? And we're going to add, am I generalizing these or am I just, oh my God, am I supposed to generalize? Let's, you know what? Let's solve each equation 0 to 2 pi. Like nobody, there's no way, there's no room in the box. So we're just going to solve between 0 and 2 pi. That's the kind of thing you can do when you're the person who wrote the notes. Tan inverse of 1.675. And I will copy that so that I can just use it. Hey, get over here. All right, so copy. And then what we want to do, so first it can just be the reference angle, that's quadrant 1. And then in quadrant 3, so if I was generalizing, I would have just done this plus pi times n and just been done. But since we're listing specific solutions because we changed it, we have to do this. So these hopefully are the kinds of problems that you can basically fly through at this point. Cosecant is basically sine. Sine is negative in 3 and 4. Our reference angle, cosecant inverse of 1.543. And these probably, like when you first start doing this, were like a little mysterious. So I think it's good when you go back and do practice problems. You know, you get a better sense of like, you're actually learning. It's just, sometimes it's painful. So pi plus the reference angle because of quadrant 3. And then because we have to do 0 to 2 pi, we can't just do the negative of the reference angle. We have to do 2 pi minus. That's actually a little thing that comes up that you got to watch out for. So to make sure that you stay within the range that you need to be in. So negative of the reference angle wouldn't put me between 0 and 2 pi. It would just be like between negative pi over 2 and 0. So we don't want to do that. Secant and positive, so that's cosine. Where's that positive? 1 and 4. Reference angle is the secant inverse of 2.332. So this is pretty good. This is soothing, you know. I'm not having to think too hard, fortunately. So we're definitely just going to get the reference angle. That's in quadrant 1. And then quadrant 4, same problem as before. We can't do the negative of the reference angle because it wouldn't be in the interval. But if we do 2 pi minus the reference angle, we're good. And then what's the last row? I mean, it can't like, there can't be any surprises in this table because we know what we're doing. So cotangent and it's negative, that's quadrants 2 and 4. And then our reference angle will be the inverse cotangent of 5.103. Okay, so quadrant 2. Yeah, quadrant 2 is going to be, I forgot to copy, hold on. Okay, I'm ready to go. So quadrant 2, it's going to be pi minus the reference angle. This. And then in quadrant 4, again, we can't just do the negative, so we have to do 2 pi minus. If this had been generalized, I would have just done quadrant 2 plus pi n. Or I would have just done the negative of the reference angle plus pi n. Either of those would be totally fine. But because we have to stay in our interval, we don't do that. There. All right, I'm going to solve the next one in this video, because why not? So let's see how we're going to choose to do it. U-substitution. This is classic U-substitution looking thing. So let's let u equal x plus pi over 2. If x is 0, then u is pi over 2. If x is 2 pi, then u is going to be 2 pi is 4 pi over 2, so 5 pi over 2. Because I have to add pi over 2. So we got that. So the equation that we're actually going to solve is sine of u equals 1/2. And then I already know that the answer is going to be over 6. So I'm going to change this to 3 pi over 6. And I'm going to change this to 15 pi over 6. So we need to be between 3 pi over 6 and 15 pi over 6. All right. So solve by thinking, right? So the first solution that we get is going to be, well, pi over 6, but it's not good enough. So what I'm going to do is I'm going to say u could equal pi over 6, and I'm just going to cross that out, 5 pi over 6. But it like gets the ball rolling, you know? And so then if I add 2 pi to pi over 6, I get 13 pi over 6. And if I add 2 pi to, so let me just do it since I'm crossing out answers anyway. If I add 2 pi to 5 pi over 6, by the way, I'm thinking of 2 pi as 12 pi over 6. So if I add 2 pi to 5 pi over 6, I would get 17 pi over 6. But then we do our interval check, and we see that we have written 2 extraneous solutions. This doesn't work. This doesn't work. One's too small, one's too big. So all we really need to deal with is the fact that this is happening, do this, and then we have these solutions to deal with. So I'm going to rewrite pi over 2. So I'm going to make it x plus 3 pi over 6. Apparently I'm using red. So x plus 3 pi over 6 equals 5 pi over 6 or 13 pi over 6. So all we have to do is subtract. So this is a little easier maybe. Get 2 pi over 6, 10 pi over 6. I feel like in this case, because there's only 2 answers, and I don't want to look too lazy, I'm going to simplify this. Okay, so I'm going to check this one on the calculator. The other one's in the table. I'm just pretty confident on. I'm sure that if they're wrong, like dozens of people will let me know. So that's not something that I'm concerned with. So let's see if we did it. So I'm going to solve sine of x plus pi over 2 equals 1/2, solving for x, and then I have to be between 0 and 2 pi. I get pi over 3 and 5 pi over 3, which is exactly what I expected. So we did it. So let me go back to the notes for one last little look. I don't know why I feel compelled to end these videos on the notes instead of on the calculator. I guess because they're like videos about doing the notes, maybe. So we did a lot of problems in this. We modified the top table because nobody wants to write plus 2 pi n on like everything. In this particular table, there's just not enough room. I mean, clearly the intention should have been to solve it there. I might go back and edit the notes so that you never even know until you watch the video that it didn't used to say that. But anyway, I'll be back in the next video. We will finish this page, so see you there.